Do you still remember this? We create a folder and a drive C, and then we create an exercise underscore SWR folder. So then we have day 4. Okay, so as of now, I haven't opened RStudio yet. So what I'm going to do is I'm going to copy this and create another file and rename it with day 5. Okay, it's day 5 now. Okay, so what I'm going to do now is I'm going to double click on day 5. So RStudio will open with the directory already changed. Okay, so I'm going to change to RStudio. Okay, let me adjust the screen a little bit. Okay, so right now I think we have from previous days, day 4, day 3, and day 4, we have written something, okay, which we don't need anymore. So right now, what I'm going to do is I'm going to remove everything. I'm going to delete everything except this line. Okay. Okay. Why don't we do this together? Okay. So let's clear our workspace. Fine. Doing this. So right now, what I want to tell you is to organize our R script. So first, I think the first session of R script should have all these. Okay, so first you clear your space. What do we call this? We call this setting up R. Okay, so okay, setup R environment or something our workspace. Okay, first we clear the workspace, and then we load necessary package. Okay, which means if it is not necessary, we don't load it. So I have introduced a little bit about Margaret R using piping function. Okay, so load Margaret R to use pipe function. You don't need to write this down. I just want to have an idea for those who missed yesterday's class. So why don't we load Margaret R? We want to use pipe function. And then, of course, we will load the library mStats. Okay, so when you write codes, one of the advantages of using RStudio is you can write a few words, okay, something like that, and then you can just press the tab key so that it will automatically select. But you have to check whether what you have selected is correct or not. Okay, so now first we clear it and we load our necessary packages, and then we read our data set. Okay, that is how you should start an R script. Okay, installation packages are for one time only. Okay, so we have done it the other day, so we don't need it anymore. Okay, so why don't we run everything? So the way we want to run everything is that at some point, if your code is not correct, or if your code is if your code produce error, then you shouldn't continue writing the codes. Okay, so that's why we should run our script from the top to the bottom every time. Okay, so that's why some of you have a little different outputs than what I have shown on Facebook posts. So that's why I'm clearing everything and start from scratch. Okay. Okay, run everything. So you can select everything and press Control Enter. Okay, the same. Okay, so from yesterday's session, we know that there are some problems. Okay, so we know that there are problems in our data set. Okay, so in age, in land capacity. Okay, if you have explored the data set, you will know this one also have invalid value, and test one and test two. Okay, I will quickly go through it because we have already discussed this yesterday. So if you miss it, then watch the video again, watch the recording again. Okay, so what is the problem with age? So we just we just check the data set age. Okay, so the problem is maximum value is more than 375.9. So how do we fix this? We fix this by using pipe function. Okay, so how does the pipe function work? It is essentially a pipe. Okay, so consider consider a pipe carry something. Okay, and then pass it down along the way. Yesterday I used forwarded, the same. Okay, so you have one piece of pipe, and you have another piece of pipe, and then you put it together. That means that whatever inside the pipe, water or any fluids or anything, it can pass down to another pipe. So the same here. We are pushing forward. We are pushing the data set forward to the next line, okay, to the next function. So this is what the symbol indicates. Okay, we put forward, push forward. Okay, so next we are going to replace the value of age if it is more than 359. Okay, so we just write it quick. Just write it as a note so that you remember what you did. If age is more than 100. Okay, so what we did is we did age, then NA, and age more than 100. Okay, so this is a little different from yesterday, right? Without using pipe function. If you don't use pipe function, you have to put your data set. Because we use pipe function, it is already pass it down, automatically pass it down the data set. So that's why you don't need to specifically mention the data set again. So it's easy. So you just specify the variable name, and then next we change minus 99 or minus 98, minus 98 in land capacity. And test one and test two. I think test one and test two only have minus 99 as invalid value. But we are not sure. So what can we do is we can check. Okay, so just leave it, and then we can check here, summarize land capacity. Okay, press Control Enter. So you can see that here minus 99. Okay, so it means that we have to replace land capacity. Okay, so one of the advantages of using pipe function is you don't have to specify, you don't have to write data set name anymore. And second thing is you can, whenever you type the variable name, it will auto suggest. Okay, so when I type land, it will auto suggest land capacity because the variable is already in the data set. So which means that you don't have to type the whole name. So it will save you time, and save you some errors, type in spelling errors. So you just press tab key. Okay, we will replace an A with an A if lung capacity is equal to minus 99. Okay, now what I'm going to do is we will put an or condition. Okay, we'll put or condition. So the vertical line here, okay, it indicates the or logical condition. So you can find the vertical line above enter key, okay, on your keyboard layout. So you press the vertical line which indicate or, okay, if lung capacity is equal to minus 99, or, and then we have to repeat it again. Okay, lung capacity is equal to minus 98. Okay, I think you got this idea. And then next, let's run test 1 and test 2. Okay, lung capacity, sorry, test 1 NA, test 1, if test 1 is equal to minus 99, and replace test 2 NA if test 2 is equal to minus 99. So as you can see that we don't have to do line by line. It is one flow containing several processes. Okay, so it is a flow. So the same, we can add several things, several processes, okay, several data management processes. And next, if you remember, what we did is we also changed WBC value to numerical version, which is replace WBC. This already discussed in previous yesterday's session. Okay, replace WBC with numerical version. How do we change write numerical version as dot numeric WBC? Okay, and then we will put this as patient 2. Okay, so as of now, I haven't run this line of comment. Okay, so just the next step is what we did is we want to change sex. Okay, sex variable, sex variable to 1 if male and 0 if female. Okay, so this is how we how we go our binary variable. So you need to understand if we are going to change this, we need to understand how it is coded in our current data set. So right now we have patient and sex, and then I'm going to tabulate it so that we can see, okay, our data. So first we need to change this 12.2 value. Okay, so what we have to do is we have to replace 12.2 to NA, because we assume that this invalid value 12.2. Okay, and then okay, so imagine that you have already run this. So up to this stage, our 12.2 is no longer here. Okay, it is converted to missing value NA. Now what we want to do is we want to check if sex is equal to male. Okay, so I've already did some explanation. Okay, so how do we do this? The first step is we want to check sets is equal to main. Okay, but when you run this line of command, it will give you an error because there is no sex object, okay, in this environment. So we only have patient data set. Because this sex variable is coming from our patient data set, we need to indicate that this is from the patient data set. So how do we indicate it? We indicate it by say patient, by specifying $sign. Okay, so observe it here. When you put the $sign, a list of all available data set, is listed here. So you can just say sex equal to main. Okay, uh, there is called a logical statement. Okay, so I'm going to delete this because it contains error. We don't want errors in our R script. So we will run this line of command by running this. So you can see that it gives you true or false. I think this is rather intuitive because when you check something, okay, the first one, the first rule, whether sex is equal to main. Okay, so it will return true or false, only true or false. Okay, so true is being male and false is being female. So I'm going to copy this and go next line. So when we change this to numerical version, okay, it is called logical values, okay, because true or false, it is some logical sense. When you change this to numerical version, it will give you 1 if it is true and 0 if it is false. So how do we change to numerical version? As dot numeric. Then you put whatever it is there. So when you run this, it will give you 1 or 0. Okay, so now we are going to use this and replace here. Okay, replace sex. Replace sex I think I discussed this. We have to use a new function called generate. We cannot use replace here because it only replace it. It does not change anything. So we were just, for the sake of demonstration, we will just generate a new variable. Okay. So here, what variable you will generate? Okay. So generate. What is the name of the variable you generate? So we will say this is gender. Okay, because our data set does not have any sex or any gender variable. So we will give it gender, and then we will say that, okay, we will use the numerical version of, here we don't need to mention the data set. So we just say sex, okay, numerical version of check-in sex is equal to main. So when you run this whole command and observe here, okay, so you will see this, we have a new patients too. Okay, I'm going to delete this because this is the flow. Okay, first we clear our workspace, load necessary libraries, read the patient data set, and then what we call this data management. Okay, we did a little bit of data management. Okay, so now we got our patient 2. Okay, so let's check the COCO of patient 2. And then press Control Enter or Command Enter if you use MacBook. and then see that we have some missing value here, okay? Because we changed minus 99 and minus 98, so we got some missing value here, and also we have missing value along the way. And then our WBC is numeric, and we have a new variable, that 26 variable, gender, which we don't have label yet, okay? And it is numeric. It becomes numeric, okay? And did you remember that we removed 12.2 as invalid value and coded as missing value? So we have one missing value. So everything is consistent now. Okay, so right now you can check the patient 2 and tabulate gender. Okay, control enter. You can see that we have one missing value and we have 0 and 1. Okay, so let's say that we don't want to include missing value, this one, okay, in our tabulation. How do we do this? We have another argument, okay? Anything within this round bracket is called argument. We need to add another argument. So we give it a comma, and then we say we will remove missing value. So remove is we already talked this. Okay, remove is iron. Okay, and then missing value is Na. Okay, so our argument is Na dot iron, which means that we will remove our missing value. So you can see that it is a logical value. So we have to say we will remove missing value. So we have to say this is true. Okay. And then when you run this, you will see the missing value Na has been removed and the percentages change. Okay. Okay, so right now I'm going to delete this again. So why don't you try it? Because I think we reached to the time limit. So right now what we are doing is we are just just reviewing what we have learned the other day and trying to make it how do we say this? Trying to make it concise and remove any unnecessary part. Okay? Okay, so I think some people join. Some people just joined. So for the past few minutes, I'm just talking. I'm just explaining why we are doing this. Okay. I think you already. I think you can grasp the idea, the concept. So whenever you do the analysis, you do exploratory data analysis, and then you make necessary changes to your data. Okay, so this comes hands in hand. So you have to do it at the same time. Explore your data and fix your data, which we call it data management. Okay, so manage your data, you explore more, and then if you found any invalid value or errors, or then you have to manage your data, change your data. Okay, so far, I'm going to delete this. So far, we have, I think we have make necessary changes, and I think it is a little bit cleaner. than the original data. So right now, you already know how to tabulate and summarize. Okay, so I just do a very quick and what do we call this? We call this univariate data analysis. Okay, you can call it anything you want. So uni is a single one. So variate is variable. So we are analyzing using one variable only. So we will tabulate and summarize. Okay. So look at this. You can tabulate. Sorry, you can use the tab function, and then you can just put the whole data set. Okay. Patient 2. So yesterday we specified variable. You can do that if you want to specifically look at variable, or you can just summarize or tabulate the whole data set. Okay, we don't specify any variable. So I'm going to run this. So remember, if you put the whole data set without specifying any variable, it will look at the data type. If it is numeric, if it is numeric, then it corresponds to some function, and then it will generate a summary measure. For a tabulation, it use any data type except from date and number. Okay, so let's run this. First, we will run the tabulation. Okay, tab. So as you can see that it generates several tabulation, and you can read it is one-way tabulation, which means that which basically means univariate data analysis. Okay, so let's take a moment and look at it. So one-way tabulation, we have name of variable, we have frequency, we have percentage, we have cumulative percentage. Okay, I think this is straightforward, and we have the total. And then if you have any labels, we can check by using codebook. Okay, if you have any labels, and it generates label. Okay, so that is for tabulation. For summarization, when you run this, you can see that it's a little bit distorted. So you just drag the window and run this again. Okay, so it will appear nice and nice. Okay, so here at the bottom we have labels. Okay, labels which we found from the codebook, and then you can also check, okay, cross-check with the codebook and look at the data type and see what kind of data type where we display here, okay, where we calculated here. So you can see that our gender, it also calculated, right? So which is basically we changed to numeric version. So it makes sense that it will be summarized here. But if it doesn't mean that we have to use this summary function. This is just a data exploration. Okay. So you have to remember here that if there is numeric, you can tabulate. Okay. Of course, you can summarize, but you can also tabulate by specifically mentioning it. Okay. So you just have to put the variable name there. So I'm going to tabulate gender. Remember, gender is how do we say, coded as a numeric, but it has a category in a sense. Okay, it has category sense, categorical sense. So we will run this. So you can see that we can tabulate numeric in R. However, we cannot summarize if it is a character. Okay. Okay. Look at WBC in patient, not patient 2 data set. Okay. Patient weight data set, we have WBC as character, so we cannot summarize it. There is an error. So we call this as a univariate data analysis. Okay. So next we are going to move on to bivariate analysis, which basically means that we have two variables. Okay, so before we move on, do you have any questions? Okay, so I think we'll move on to bivariate analysis. Okay, so first, we will look at, we will explore our data set by looking at two variables at the same time. Okay, so first, we will summarize. We will look at group summary, which is when you have your variables are numerical and categorical. So if you have one numerical variable and one categorical variable, and you do group summary measure, how do you group? You group by categorical variable. Okay. Okay. So do you have new functions? No. You can just do it with a summarize function. Okay. So how do we do this? Okay. Let's consider an example. For example, we want to summarize age by sex. Okay, so we want to summarize. Okay, you just say sum age by sex. Okay, so sex is a categorical variable. You can say this is gender, okay, or sex. If it is a categorical variable in a sense, then you can use it. Okay, so we will sum. Okay, so we have to specify that data set because we are not using pipe here. So we have to say patient 2. Okay, so patient 2 is the correct data set. We say age. Okay, we summarize age. Okay, and then you specify by. Okay, is equal to sex. So you summarize age by sex, and then you run this. Okay, let's see a little bit, drag a little bit. So you can see that. So you can see now we have three categories because we haven't removed missing value, right? So we have female category, male category, and missing category. And you can you can compare. Okay, so if it is female, then mean is around 50.6. If it is male, then it is 51.6. If it is missing, it is 56.4. But basically, it has only one observation, which basically means that we cannot calculate standard deviation, right? So that's why it becomes NA. So there are three additional measures: normality, ANOVA, and Crusher-Wallace, which we are going to discuss on week 2. Okay, because these are inferential statistics, so just leave as it is and then focus on the exploratory descriptive statistics. But if you remember, when you summarize single variable, there are two additional measures which is not shown here, okay, which is minimum and maximum. Okay, so here we have observation up to that quartile range, that quartile. So basically this is called the group summary measure. So this is how you did a group summary measure in using mStats. Okay. Okay. So let's say that, okay, I want to put multiple variables and look at look at this look at this group summary measure by sex for multiple variable. So we can do this by just writing, by just putting every variable there. Okay, every variable we want. So we will put age. Okay, what do we want to know? We want to know that language day add to test 2. Okay, so we can use the colon separator here. Language day add to test 2. And then you give it a by argument and put sex. Okay, so the same one, but you have to specify this one. Okay, so you can put multiple variable here. However, you cannot put multiple bind category. Okay, so you can only use one, because otherwise it will be very complicated. Just make it simple. To simplify it, just use categorical variable one at a time. So we will run this and see how the output appears. Okay, so I'm going to drag a little bit here, then check the output. Even so, I need more space. Okay, so I think you can do this. You can do multiple variable at one time, but I don't think that is a good idea because it's a little bit complicated to look at, right? So for every numerical variable, you have 3 categories. So for age, you have 3 categories. For female, you have, sorry, for language day, you have 3 categories. WBC, RBC, BMI, test 1, test 2, you have 3 categories. Okay, so it's a little bit annoying because as you can see, we have NA for every category, right? So we need to remove that NA, missing value. So just specify NA.IN is equal to true. Okay, we will remove the missing value. So I think when we drag this one and run this output again, so you can see that our missing category has been removed. Okay, so let's take a moment and see what is being displayed here. So the first part is group summary measure, which is basically 2 categories for every variable, numerical variable. And the last part, this part, is the summary measure for univariate data analysis. Okay, so that's why you don't see t-test and recursion. Okay, I think if I scroll up, you see that there is this test is different, right? Because there are 3 categories, which we will discuss next week. Okay, we use Innover and Crystal Wallace test. Now we only have 2 categories, so we use the test and recursion. Okay, so but anyway, we will discuss more on next week. So this is how you do group summary measure. Okay, so right now what we are interested in is descriptive statistics or exploratory data analysis. So that's why we didn't discuss anything about whether it is significant or what is p-value, how to interpret it, because that is what we are going to discuss next week. Yes, Tinley? Is there a question, Tinley? Hi, Tinley, I cannot hear you. Do you have a question, Tinley? Still cannot hear you. Okay, I think he's typing. Okay, do you have any? So, what about other people? Do you have any questions? Or can you follow?
No questions so far. I followed.
Okay, so the question here is, how can we specify the number of decimal points in the output? Okay. Okay, that's a very good question. So we will see this example, okay, of age. So what I'm going to do is I'm going to copy this and I'm going to paste it. Can you mute it? Okay, so let's run this to see the output again. Okay, so we have this one. Okay, there right now we use 1 decimal point. So I use 1 decimal point for every output by default. So you can change this. Okay, you can change this by specifying. So give it a comma because we will put more argument. Okay, and then you can press tab key. So other arguments, available arguments will appear. Okay, so we got any.im, which we discussed here. Okay, next one is we have ind, which is basically specify rounded numbers. So that is exactly what Dr. Tinley asked. So we will give, okay, so for demonstration purpose, we will give rounding value of 5. Okay, so we want 5 decimal point behind on every value. Okay, so we can do this by running. So you can see every value will have 5 decimal point now. So that is how you change decimal points in these comments. But I doubt you really need it. For some clinical values, like put a CN level or something, I think you don't even need more than 3 decimal points. Okay. Okay, so any more questions before we move on? So can you understand the concept here? The concept of group summary measures. So what we are doing now is we are looking at the relationship between 2 variables. Okay, so if you look at, if you just look at the value, if the category is female, age is 50, which is basically 51. If it is male, age is 52. So there's not much different, right? But also it depends on what kind of the context. Okay, so if you consider the Buddhist level, even 1 digit difference is critical, right, in Buddhist level. Okay, so another questions I got here is in here. Okay, why don't we use patient to replace it? Is that right? Question is. Okay, anyway, I assume it is correct. Okay, the reason is this is a change of, this is a flow, this is a change of series that is happening. So if you look at here, we have patient data set, which is the original data set. We haven't changed anything yet. Then we put it to the next line. And then we replace it with NA. And then we we take this data set, okay, with modified age, and we put it to the next one. So it's like carry over. These changes are carried over to the next line, okay? So, and then to the next, on this line, we change the land capacity. So the modified data set now has age and land capacity modified. Then we put it to the next line, and then age, land capacity plus one. Can you hear me? Can you hear me? I see some internet connection is not stable. Can you still hear me?
Yes, we can hear you.
Okay. Okay, so as it goes on, every changes we make along the way is carried over. So that's why when we reach to the last line, it is no longer the patient data set, but we start from a patient data set. Okay, that's why. Can you understand the concept here?
Yes.
Okay. This concept is also the same. If, okay, let me open yesterday script. Okay, this is day 4 script. Yesterday, what did we do? We also use the patient data set at first, and then whatever we got here, we assign back to patient 2. And then to the next line, look at it. We no longer use patient data set. We use the modified one. So that is how you carry over the changes. Otherwise, when you always use the patient data set and put it on patient 2, yeah, it is not good, because whatever changes you make, it is not carry over. Okay, so that is the concept. But I think, my personal opinion, I think using the piping function makes whatever you write very easy. Okay, so any questions? Okay, so no questions. We will move to, okay, so yes means you have question or no?
No questions.
Okay. Okay, let's move to the what we call cross-tabulation. Okay. If you have numerical variable and a categorical variable, you use group summary measure. Okay. And then if you have two categorical variables, you use cross-tabulation. Okay, so let's find some category. Okay, okay, how do we check our data set? So we use codebook and then patient 2. Okay, then we see we will look for some categorical variables to cross-tabulate. Okay, let's see. We want to cross-tabulate, say, family ages and smoking ages. Okay, let's look at here. We want to cross-tabulate sex and family ages. Okay, family ages, I think it is family history. Okay, family ages is family history. And we want to cross that by sex. Okay, so the same principle applying here. It's similar with a sum. Okay, just first you mention the function name, tab, then you put data set, patients, then you put family ages or sex. Okay, right now it doesn't matter, the order doesn't matter, you can put either way, and you specify by then sex, which is basically called contingency table or cross tabulation. What happens? Okay, so basically it has an error because our data has only one NA in sex, right? So that's why we have to remove NA. Okay, because in calculation, I think there are some errors. I think I need to fix this, but because there are any missing category, and that's why the calculation cannot be, you know, uh, produce a value. That's why there is an error. So anyway, when you remove the missing value, okay, and a dot .im is equal to true, then you will see this cross tabulation. Okay, so we have this variable on the left side, and on the right side we have sex category. Okay, so as you can see that we also need to fix this, right? Minus 99 is still there. I think for the smoking ages too. Okay, so why don't we fix this? Why don't we go back to here? Okay, why don't we go back here, and then you can continue place and NA to family HS, okay, HS, if they are minus 99. So basically we just say family HS. Okay, so you can select it and put NA if family HS equal to minus 99. Okay, so next line, smoking HS, NA, smoking HS is equal to minus 99. Okay, so let's run everything again. Okay, so how do we run everything? Control Shift Enter. Okay, so you need to understand, you need to remember that when you run Control Shift Enter, there should not be any error on the command. Okay, along the way from top to bottom, there should not be any errors. If there is an error, running the script will stop at the error and it will not continue. So that's why you need to fix. You need to make sure that every line should not have any errors. So if we look at this, okay, so if it is fixed now, okay, let's see if we remove this na.im, it should appear. Okay, it's still not it's still an error. I think I will fix this on next issue, next version. But right now we can have this. Okay, so the same principle goes, right? So you just, okay, copy this and remove this. Then we put smoking HS. Okay, it is multiple variable at the same time. Then when you tabulate it, there's cross tabulation by sex. Now we got family HS. Now we got smoking HS. Okay. Okay, so a little bit different from summarization. We have chi-square and exact test. So which we will discuss next week. So right now, this is how you assess the relationship of two variables. If you have one numerical variable and one categorical variable, then you use group summary. If you have two categorical variables, then you use cross-tabulation. So all these commands you just specify by. Okay, so before we close today's session. Or what if you have two variables? Okay, so basically, if you have two numerical variables, you find correlation. Okay, I think we haven't discussed correlation, but I think we were talking about correlation on linear regression. So just remember, if you have two categorical variables, then you find correlation. So what is the correlation? Correlation is a quantity. Correlation is a value that that state the relationship between two numerical variables. Okay. So a few principle correlation start from -1 to +1. Okay. So that is correlation. It can range. Its range is from -1 to +1. How do we interpret it? Okay, -1 to +1 means that there is a zero. Okay, zero means no correlation. Means that there is no relationship between the two variables. Okay, -1 is perfect negative correlation. And +1 obviously is the positive one. Okay, so I'm not going to write this. Okay, what do we mean by positive or perfect correlation? So it means that, say, for example, I think for children, we have weight and height, and also age for heights. These are correlation. So it means that the more children, the children, I think if the height increase, the weight should also increase. That is positive correlation. Okay. So if you have two variables, both increase, then it is positive correlation. If one is increased, then another one comes down, decrease, then it is called negative correlation. Okay, perfect mean if one unit increase, one unit increase. That is positive, perfect positive correlation. If one unit increase in one variable and then one unit decrease in another variable, it is called negative, perfect negative correlation. Okay, anyway, we want to look at the correlation. Okay, so correlation is not a function from mStat. It is based on. So you cannot just put the data set. Okay, so we have to indicate that using a new function. Okay, new function in R based on to indicate the data set. Okay, which is width. Okay, and width mean with the data. Okay, basically what it's trying to say is with this data do this. Okay, using this data do this. So we say width, that is the function name, and then we give round bracket, and then what is that our data here? Our data is patient 2. Okay, and then the function for correlation is COR. I think it's easy to remember, right? COR. Then you put the two variables. So we want to look at, okay, our numerical variable, let's see WBC and RBC, okay? We want to look at how they correlate each other. And then you can run this. And there is an NA, which is a missing value because I think because there are missing value inside WBC and RBC, so that's why. Why don't we try test 1 and test 2? And think, wait a minute. Okay, so I think we need to give it, go back to RVC, WBC and RVC. And what we need to specify is we need to use is equal to, so here you see this optical corridor string, so we can uh, complete observation. Okay, because there are missing value, okay, you can check the code book and there are missing values. So if missing value, say if you 1 plus NA basically is missing value, okay, something like this, okay, 1 plus NA, it will give you an A because you cannot add to 1 because we don't know what is in not available is NA value. So that's why the return value is NA. Okay, so anyway, we have to remove the NA. Okay, so I think this is the end of today. And if you have any question, just post because it's almost going to end the meeting. Okay, so if you have any questions, just post on the Facebook, and then we will see you tomorrow. Okay.